Okay, we're looking at mixed exercise 8 from the first year core textbook. So we're on binomial expansion. So question 11. So you are given the binomial expansion formula on the formula sheet. Okay, and let's do this expansion. Okay, so I'm expanding 1 plus 2x to the power of 12. And I only need to go so far as the x cubed term. So for us, a is 1, b is 2x, and n is 12. So it's going to be 1 to the power of 12 plus 12, choose 1, 1 to the power of 11 times 2x. So each time the power of 1 is going to reduce by 1. So 12, 11, next power will be 10. Obviously, they are all just going to be 1. So you don't really need to write the powers when you've got a 1 there. But I'll write them so we can clearly see the pattern. So then it will go 12, choose 2, 1 to the power of 10, and the 2x will be squared, and 12, choose 3, 1 to the power of 9, and the 2x will be cubed. So each time the power of 2x is going up by 1, the power of 1 is going down by 1, and in every term, the powers should add up to 12. Okay, so let's just simplify that. So 1 to the power of 12 is just 1. Then I've got, so looking at this one here, that I've got 12, choose 1, which is just 12. So that's basically 12 times 1 times 2. So that would be 24x. Then looking along to my x squared term, and you just need to be really careful with the 2x here. So 12 choose 2 is 66 times 1 to the power of 10, so just times 1, and then it's going to be times 4 because that 2 is also getting squared, so it is important you put brackets there. And then just looking at the x cubed term, so it's going to be 12 choose 3, which I get as 220 times 1 and then times 2 cubed, so that's going to be times 8, so I get that as 1760 x cubed. Okay, so I don't think we're going to need the formula anymore. So by substituting a suitable value of x, which must be stated, find an approximation of 1.02 to the power of 12. Okay, so we've seen that idea come up a few times now. It's quite a common part to these questions. So we have expanded 1 plus 2x to the power of 12. They are asking us to approximate 1.02 to the power of 12. So as those powers are equal, I can just pretend they're not there. So it must be 1 plus 2x must equal 1.02. So if I minus 1 and then divide by 2, I get x is 0.01. So we've done the, so value of x, which must be stated, so that's the value of x we're going to use. Okay, and then all we're going to do is substitute that value of x, so 0.01, into our expansion. So I just need to show some evidence of my method. So it's going to be 1 plus 24 times 0.01 plus 264 times 0.01 squared plus 1760 times 0.01 cubed. Okay, and then I could do that without a calculator. That wouldn't be too bad, but I'm not gonna. I'm going to just type that straight into my calculator. Okay, so assuming I haven't typed any of that in wrong, I am getting 1.26816. And the way I can just check if I think that seems reasonable is actually just go back and put that into my calculator. And I'm expecting this, my approximation to be very close. So yeah, so when I put that into my calculator, and I wouldn't actually write this down normally, I would just put it into my calculator and check, but that's what I get as the actual answer. So I would be pretty happy with that approximation. Okay, so magic. So I would always write the full answer out that you get, and then let's just round it to 3 significant figures, but definitely write the full answer out, otherwise it might just be that you've got it from your calculator. Oh, okay, having said that, right, I had just answered part C and then rubbed it out. So let's do that now. So C did say find the actual answer. Really forgotten what it was to, 1.02 to the power of 12. So that'd be a very nice easy mark to get in an exam. So the actual answer I mean, this may not be the exact answer because obviously your calculator only works to a certain degree of accuracy, so this may also have been rounded, but what am I doing? 9.5. Yeah, so do be careful. Make sure for these questions you do triple check it and make sure you have written down the exact answer. Okay, and then we want the percentage error. So basically, we want the percentage error between our approximation, so that value there, and what the actual answer should have been. So, you always choose the wrong pen there. Okay, so that's going to be the difference between them. So the actual answer minus our approximation. And it should always be as a percentage of the right answer. So as a percentage, to double check it doesn't say anything strange in the calculator. So percentage error. So when you're doing percentage error, you're doing it as a percentage of what it should have been, of what the right answer was. And I think we're going to get a very low percentage error here. And then as it's a percentage, I'm going to times that by 100. Okay, so just bear with me whilst I type into the calculator. In fact, if I was sensible, I just wouldn't clear the previous answer, would I? Okay, so answer minus 1.26816 over answer times 100. Yeah, that is not bad. So as a percentage, I'm guessing it as that. So written out of standard form, it's a 0.00645% error. So I think we'll take that as being a very good approximation. Let's quickly check those answers. Yeah. Yes, brilliant. I think that's what we got for everything.